Okay, so now that the meeting is being recorded, welcome again everyone to CE3211 Principles of Steel Design. So ayan, start na tayo. So welcome again. Welcome once again. So our lesson for today would be about the base plate. So what is a base plate? So kung ano man yung nakikita nyo dyan, teka, alisin ko lang yung muna yung mukha ko and yung calculator natin. So what you are actually seeing right now is what you call engineering failure. So basically, that should be a base plate. So confirmation everyone, do you see my laser pointer?
Yes, sir.
Yes, sir.
Okay, so this should be a base plate, but it would be common sense of us na sabihin this would be a failure kasi dapat meron siyang pedestal. Okay, pinakita ko lang yan kasi nung nag-search ako ng Google image about a base plate, nakita ko yan. So, pakita ko na din lang sa inyo. Okay, so after that, balik ko yung mukha ko and yung calculator natin. So, this is what you would be calling a base plate. Kung ano yung nandito yung tinuturo ko sa aking laser pointer. So, this is to be your compression member. So, column to. And it would be self-explanatory already for you na third-year engineers na sabihin ang column members natin is to be subjected with a compression force. So if this is to be your force, so kung ito yung force natin pababa, since this is to be a compression, it would transfer your load to the base plate. And once again, ito yung base plate natin, yung nasa baba. Okay, so ano nga ba ulit yung base plate? So as per the definition that I have read a while back, so column base plate is the critical interface between the steel structure and the pedestal. So if this is to be your pedestal and this is to be a concrete pedestal, kung ano yung transition from the steel section natin na compression to the column pedestal, yun yung base plate. So the use of the base plate is to distribute the load. So if this is to be force P, U, kapag ganito yung force niya, of course, hindi naman magandang diretso agad siya sa concrete. You must have a bearing plate. So by bearing plate, that is to be our base plate para ma-transfer yung load niya dito sa concrete structure natin equally. So okay ba tayo doon guys? Naintindihan ba?
Yes, sir.
Yes po.
Okay, so next slide na agad tayo. So in engineering books, this is what you would be seeing. Ito yung ating anatomy ng ating base plate. So if this is to be your steel column, and during our last pre-recorded lecture, we discussed about the analysis and design of compression members. And steel column is the most common compression member. So sa truss structures nyo, meron din kayong mga compression members doon. Pero itong steel column, ito yung example natin ngayon. So if this is to be designed using the parameters that we have chosen for the design for compression members, once again, ito yung ating load. Then, itong bearing plate natin is yung magre-resist sa kanya. Then, after that, after niyang may resist yan, ipupunta niya ngayon yung load doon sa ating concrete. So, statics of rigid bodies. So, ganyan dapat siya. So, equilibrium yan. So, erase ko yan. Okay, so this would be the different parts of, the different parts that we would be needing for the design of base plate. So, this is to be the base plate proper itself. So, ito, kung nakikita nyo man ng aking sinusulatan. And, meron tayong washer and thread na nakakabit sa anchor rods natin. And our anchor rods is to be connected, wait lang ayaw ng aking pen, is to be connected in the column pedestal and the base plate. Okay, so erase ko muna to para may papakita din ako sa inyo. So, below the base plate is what you call grout. And this grout right here is what you call a structural grout or a non-shrink grout. So, ang gamit ng non-shrink grout natin is for the equal distribution of loads from the base plate to the concrete pedestal itself. So, ito, sinabi niya dito, concrete footing. So, itong concrete footing natin is actually concrete pedestal. So, I think it would be better for us to call it concrete pedestal instead of a concrete footing. Kasi, under here, meron pa tayong footing actually. So, parang ganyan yan. So, ayan. So, basically, ganyan siya. Pero Control Z ko na kasi ang pangit ng drawing ko. Okay, so after that, we must have our shear lug. So, itong shear lug natin is parang in-offset lang to para magkaroon tayo ng shear resistance. So, okay, with you seeing those, balik tayo dito sa slide na to. So, once again, this would be the threads and the washers. And yung nasa ilalim nitong threads and washers na to is yung anchor bolt. By the way, ito yung anchor bolt natin. Then, this is to be the base plate. So, ito yung base plate natin. And this is to be the non-shrink grout that I was saying. So, ito yung non-shrink grout natin, yung yellow. Guys, nakikita nyo ba yung yellow na dinodrawing ko?
Yes po.
Okay, so that is to be the non-shrink grout. So once again, ang gamit ng non-shrink grout is for the equal distribution of loads from the base plate to that. So balik tayo dito. So once again, itong force natin itong force PU natin is mapupunta sa base plate, then ipupunta niya yung load sa non-shrink grout, then ultimately sa ating concrete pedestal. So if you would be looking at it from the tops, so ito yung top view niya. Na-imagine nyo ba guys? Ito yung flange niya. Ito yung flange. Dito kasi sa example natin kanina, ito ano to hollow steel section to. So hindi siya flange, but ito, flange siya. Okay, so this would be the different parameters that you would be needing. And we have a base and we have a depth of the base plate. So, itong flange na to na-design na dapat natin to, and yun yung pagbabasihan natin ng ating design for the base plate. But for our computation here, this D right here, teka, lipat ko lang ng color. Okay, so this value of D right here, itago natin sa pangalang N. Bakit N? Mamaya nyo malalaman. So, ang dimension natin ng base plate is B and N. So, this would be the base and the depth of the base plate. And sapat na ba yung hanapin natin itong B and N natin ng base plate? So, hindi pa. We also have our thickness. So, our thickness right here would be, well, yung self-explanatory, yung thickness na nandito. Yung thickness ng ating plate. So, this is to be in top view, kaya hindi ko mapakita kung ano yung thickness and whatnot. Pero, ayan, B times N, I mean, B by N by T. So, this is the only thing that we would be computing for the computation for the base plate. Okay, so sa mga hindi ko students dito, kung under kayo kay Ma'am Suba or kay Sir Kanjao, I don't know if napag-usapan nyo na to. But if so, review nyo na lang to. Okay, so what would be the steps in designing your base plate? So, along with the other problems, the first thing that you should do is so step 1 is to get the properties or the parameters. So, get properties. So, if this is to be your base plate, so ano ba yung mga kailangan nating parameters ng properties? Of course, we must need the grade of the base plate. And if this is to be your figure, kailangan nyo ding malaman yung area na itong kinukuha ng ating compression member. So in that case, if this is to be the base of the flange, and this is to be the depth of the flange, kailangan natin yung B and yung D niya. Okay, so with those being said, ang kailangan natin dito would be the FY, then the B. BF pala yun. BF. So, the base of the flange of the compression members, the compression member and the depth of the compression member. So, ano pa ba? Okay, since this is to be on top of a concrete pedestal, and ang concrete nyo, what would be the strength of the concrete? So, that would be FC prime. Confirmation, guys, meron ba kayong reinforced concrete subject this sem?
Meron, sir.
Okay.
Meron, sir.
Okay, so alam nyo naman na tong FC prime natin. So this is to be the compressive strength, the 28-day compressive strength of your concrete. Etong FC prime na to. Okay, so lagyan ko lang ulit ng note to. This is to be for the compression member on top. So, CM. Okay, next up, after you have listed your properties already, the next step is to, ano ba next step natin? Yung factored loads. So, compute for the factored loads. So, I wouldn't be discussing any further on this step number 2 right here. Basta alam nyo na kung ano yung LRFD and kung ano ang ating ASD. So, ang ASD natin would be the service loads. And as for our LRFD, that would be our ultimate loads. Okay, so after computing for the factored loads, so step 3 naman natin is to compute for the bearing area. So, compute for the bearing area. Okay, so paano ba natin makompute yung bearing area natin? Okay, so we would be using the nominal stress. So hindi pa na tayo gagamit ng factored load dito sa pagkuha ng area. And our nominal stress is equal to Pn, right? Teka, palitan natin yung color ng mas bright onte. So Pn. So if that is to be Pn, paano ba natin makukuha yung value ng Pn? So Pn is equal to 0.85 Fc prime area. So mukhang familiar na kayo dito sa ating equation na to kung reinforced concrete na kayo. So sa reinforced concrete nyo, 0.85 Fc prime AB, etc. yun, no? But in this case, area 1 lang to. So itong formula na to is only applicable if the base plate, so base plate, the area of the base plate is equal to the area of the concrete pedestal. So concrete pedestal. So anong ibig sabihin ko doon? So balik tayo sa previous slide natin. So if you can see here, guys, nakita nyo ba yung figure? Itong tinuturo ko, yung ating drawing.
Yes, sir.
Okay.
Yes, sir.
So, ang ibig sabihin ko lang dun sa slide ko kanina is that if your base plate, so itong base plate natin, kung same siya ng area sa ating concrete pedestal. So, if they would be the same, you would be using this formula right here. So, what if your area for the base plate and the concrete pedestal isn't the same? So, if that is to be the case, you would be using this formula instead. So, Pn is equal to 0.85 Fc prime times the square root of A2 over A1, where A2 would be the area of the concrete pedestal, so A conc P, and your A1 would be the area of the base plate. Amplituin ko na nga lang para hindi kayo malito. Base plate. Okay, so na-realize ko lang mali ang ating placing nito. So wait lang, ilipat ko lang ito. Lagay natin siya dito. Okay, pero meron tayong bagong parameter dito, bagong limiting factor. If you would be using this formula right here, make sure that it would be less than or equal to 1.7 Fc prime A1. So, ayan, may memorize nyo yan. Yung mga yan, madali lang naman yan. By the way, guys, itong mga formulas na to, nakuha natin sa NSCP 2015, page 5-104. So, pakita ko lang. So, itong 5-1, itong NSCP nyo sa page 5- ewan ko nakikita nyo, liwanag ata. Basta 5-104. Yes, doon nyo na lang i-check yung formula na aking pinagsusulat kanina. Okay, so what would be the next step? So the next step is to check the limits. So, step 4. Okay, so ano ba yung limits na yan? So, ito sa step 3 natin, na-solve natin yung value ng A1. Oh, by the way, hindi pala natin sinolve yung A1, sinolve natin yung PN. Teka lang, asan ba yung aking laser pointer? Okay, so it is said here that in step 3, you would be computing for the bearing area. Pero ang pinakita ko na bang formula sa inyo would be the nominal stress is equal to 0.85 FC prime area 1. So, yun lang, solving for the unknown. Ang unknown mo dito would be A1, your FC prime would be given, and your PN would be derived from here sa factored loads natin. Oh, by the way, ito pala, hindi pala factored load itong AST. Pero ang AST kasi natin, that would be unfactored. So, you would be using that as your PN. Pero, you would be getting the value of yung nominal stress using the this formulas right here. So, itong PU is equal to VPN, and itong isa is PA is equal to PN over omega. Okay, so using those, you would be solving for your value for A1. So, kung ano man yung applicable dito sa dalawang formulas na to, yun yung gagamitin nyo. So, once that you have solved for the value for A1, you would be comparing it with the limits. So, ito yung isang limit natin. Itong 1.7 FC prime A1. So, if nakuha mo na yung bagong area 1 mo, ngayon, i-compare mo siya dito. So, nasan ba yon? Sulat ko lang ulit. So, 0.85 FC prime square root of area 2 over area 1. Make sure that it is less than or equal to 1.7 FC prime area 1. So, make sure na tama yan. If hindi tama, gamitin nyo yung dito. Okay, so isa pang limit natin na dapat, if this is to be your steel member, dapat mas malaki yung dyan sa area na yan ang ating base plate. Kasi ang pangit naman tignan kapag yung base plate nyo is eto. So for example, yan yung base plate nyo. So instead of pangit, I mean aside from pangit siya tignan, it is very, sorry for the word, but it is very stupid if that would be your base plate. Kasi hindi mo naman matatransfer yung load netong lahat ng inyong compression member to this small base plate right here. So with that being said, dapat yung minimum nyo na base plate would be the size of the compression member itself. So i-drawing natin para lang makita nyo. So this is to be the minimum base plate. I mean, the minimum area of the base plate. So yan dapat. Okay, so with that being said, your area 1 should be, ibahin ulit natin yung color. Your area 1 should be greater than or equal to the area of the, ano ba tawag dito? Of the compression member. So that would be B base times base of the flange times D. So if this is to be the base of the flange, so base ng flange times yung depth. Yun lang naman yun. Okay, so if you have already computed for those, next slide tayo para may space tayo. Anong number na yun? 4. Okay, so step 5. So if you have already solved for the bearing area and kung na-check mo na siya with the limits, ano ngayon ng ating step 5? Teka lang. Okay, so ang ating step 5 would be to determine the base plate, yung dimensions ng base plate. So, ayan. So, ngayon, pag nahanap mo ng inyong dimension ng base plate, saka ka pupunta sa step 6. Pero paano ba natin hanapin yung dimension ng ating base plate? So we would be having certain formulas here. So ang first formula natin would be yung n. So if you can remember from the previous slide, ito pinalitan natin ng n, no? So yung buong depth na yan, which is n, that is to be equal to the square root of area 1 plus delta. Where delta, teka lang, where delta is equal to, ano na yan, 0.95D minus 0.8 BF. So that is to be times 1/2. So divided by 2. So times 1/2 ko na lang. So divided by 2. So ano ba yung nangyari dito sa formula na to? So ang ginawa lang natin dito if you have already solved for your value for A1, pag square-root natin yan, so for example na square ito, kinuha lang natin siya ng dimension na, yung isang dimension niya, then dadagdagan lang natin ng delta. So if for example that this is to be A1, ang nangyari dyan, oh by the way, ito kasi yung nasolve mong A1 dito is mas maliit talaga dito. So as for the value for A1, nagdagdag ka lang ng delta para makuha mo yung isang dimension. Okay, so once again, itong square root of A1 na to, kinuha lang natin yung isang dimension ng area 1 na to, tapos nagdagdag lang tayo ng delta. And yung delta natin is this. So after that, for us to get the value for the base, so base, palitan na lang naman natin. So for your base, that is to be area 1 divided by n. So, nakuha na natin yung n natin. Palitan natin yung color para colorful tayo ngayon. So, n. Okay. So, saan ba nanggaling tong formula na to? So, as you can remember from your solid mensuration classes before, area is equal to, if the area is to be a rectangle, that is to be base times depth. And yung depth nga natin dito is n. So, A is equal to Bn, cross multiplication, then you would be arriving at an equation of B is equal to A1 over N. Okay, confirmation guys, nakakasunod pa ba?
Yes, sir.
Yes, sir.
Okay, so that is to be for step 5. So, kapag meron ka na ngayon na value ng ating B and ng N, so, ang conclusion mo dito, you would be having you would be having the values of B and your N. So, the next step, yung step 6 natin, is to check the bearing stress. So, check bearing stress. So, paano ba natin i-check yung ating bearing stress? So, ito dapat. So, VPN should be greater than or equal to PU. So, this is for LRFD. And PN over omega should be greater than or equal to your allowable stress, so PA. And this is to be for ASD. So, if you can remember yung ating value ng phi and ng omega, so phi and omega, from the previous discussions, kapag yielding, di ba, 0.9 and 1.67, then 0.75 and 2 kapag rupture. Dito naman sa bearing stress, we would be using the values of, ano na nga ba dito? 0.65 and 0.6, 0.65 pala isa. 0.6 and 2.31. Okay, isa palang tip guys, kung for example naalala nyo yung phi ng isang nagagamitin mo para sa computation mo, for example sa bearing stress, kunwari natandaan ko lang is yung phi which is 0.6 and nakalimutan ko tong 2.31, dapat yung yung product nilang dalawa, so lagyan ko ng tip dito, so the product of them should be approximately equal to 1.5. So if we are to use the calculator, so guys, nakita nyo ba yung calculator sa inyong left side ng screen?
Yes, sir.
Okay, so pag i-multiply ko to, 0.6 times 2.31, so approximately it is equal to 1.386. So isa lang ibig sabihin yan. Nagkamali ako sa value ko ng phi. So ano ba yung tamang value natin ng phi? So 2.6 and 2.31 yung una kong na-check. Okay, so before that, i-confirm ko lang yung ating theory na yung 1.67 and 0.9. So, yan na 1.503 yan. So, that is to be for the yield. Then, as for the rupture, ano na yung sa rupture natin? 0.75 and 2. So, if you would be multiplying them, 1.5 ang ating approximate value. And as for dito sa bearing, 0.65 nga talaga ang dapat natin gamitin. So, 0.65. So, tama pala yung unang assumption ko. Ayan. Okay, so if you are to multiply 0.65 and 2.31, 0.65 times 2.31, that is to be approximately equal to 1.5. So, 0.65 pala talaga ang ating phi. So, ayan yung ating pag-check ng bearing stress. Okay, so after that, kompleto na ba tayo? Meron na tayong B and meron na tayong N. So the next step that we should take, mamaya yan, is to get the value of the thickness. So 7. So step 7 natin is to determine the thickness. Okay, so we would be having different formulas for the determination of the thickness. And the first one, so thickness is equal to L. So L times the square root of 2 PU over Phi FYBN. So ayan siya. So this is to be for LRFD. So LRFD yan kasi meron tayong value ng Phi. And as for the AST, so T is equal to L times the square root of 3.33 PA, so the allowable stress the allowable load, the allowable strength divided by FYBN. So ayan, ito is to be for ASD. So saan ba nanggaling itong 3.33 na to? Kapag i-compare mo dito, actually ganito kasi siya. So note na lang to. Dapat ganito yung value sa loob ng square root na yan. So that is to be 2 times omega, and our omega for bending. Kasi bending nga naman yung chine-check natin for the thickness. So bending yan. So that is to be ano ba sa bending? 1.67 times PA and whatsoever. And if you would be solving for this, ang labas dyan, 3.34. Pero basically kasi itong 1.67 natin, dapat 1.666 yan na non-ending. So if you would be using that, dapat ang sagot mo dito 3.34. So thus, ito yung equation natin. Pero kalimutan na muna natin yan, baka malito kayo lalo. Basta yan yung ating formula. So what would be the value for your L right here? So itong L na to and itong L na to, saan ba natin kukunin yan? So the value of L would be the greatest value between M, N, and lambda n prime. So ano ba tong M, N, and lambda n prime na to? So if you are to go back to this certain figure right here, ito may n tayo dito, N, M, and M. So kung ano man yung tawag dito, pinakamalaki dyan sa mga yan, yun yung gagamitin mong value ng inyong letter L. And kita naman dito sa figure kung paano nyo isi-solve yung value ng n. So that is to be base times 0.8. So kapag may solve nyo yun, pag yung base times 0.8 BF, teka nga, Palitan ulit natin yung color. So, B minus 0.8 BF ang matitira sa inyo would be this length right here. So, if that is to be the length that you have that you have solved, divide nyo lang by 2 to get the value of n. So, ganun na din yung dito sa M. Yung sa M naman, the total depth or yung n natin minus 0.95D divided by 2 para makuha mo yung M. So, with those being said, so, our value of for M would be, nakalimutan ko. Yung M natin, N minus 0.95D. So, N minus 0.95D. Of course, we would be dividing this by 2. And as for the value of our N, that is to be B minus 0.85 BF divided by 2. Tama ba? 0.8 pala. 0.8. So, 0.80 BF divided by 2. So, ito namang isa, lambda n prime. So, sa classroom discussion natin, we would be assuming that lambda is equal to 1. Kasi puro ganun muna yung cases na gagawin natin para di kayo malito agad. So, our n prime would be, na yung ating value ng n prime according to NSCP. Teka, kalikutin ko lang si NSCP natin para makuha natin si n prime. So, lambda n prime na natin. Lambda n prime is equal to the square root of the depth times the base of the flange divided by 4 o kaya 1/4. So, ayan lang yan. And after that, you have solved for them. Makukuha mo na yung thickness, no? And ultimately, you would be arriving at your answer na yung ating base, ating depth, and ating thickness. So, pag nakuha na natin yan lahat na yan, so basically, tapos na tayo. Okay, so before we start with the computation part, are there any questions or naintindihan naman ba? Okay, mukhang walang question. Naintindihan naman ba? Guys, sagot.
Yes po.
Ayan, how about?
Yes, sir.
Okay, sige. Okay, so mag-sample problem na lang tayo. So, in this problem, a wide flange, a W section, itong W section natin is a wide flange. A W section is used as a column and is supported by a concrete pedestal as shown. So, ito daw yung ating W section and it would be supported by this concrete pedestal. The column will support a service dead load of 450 kilonewtons and a service live load of 650 kilonewtons. The concrete strength is 21 megapascals. So, yung strength daw nito is 21 megapascals. And determine the dimension of the base plate using LRFD method and NSCP or AISC specifications. Then use A36 for the base plate. Okay, hindi ko nasulat dito. So, itong base plate daw natin is A36. So, hindi ko nilalagay yung solution. Hindi ko na isusulat yung solution, but our A36 steel has a yield strength of 248 MPa. Okay, so ayun. The first thing that we should do is to, na yung step 1 natin? So, get the properties. So, okay, so step 1 nga muna tayo. So, properties. Okay, so if we are to get the properties, ano na ulit yung mga properties na kailangan natin? That is to be the Fy, Bf, D, and Fc. Itong Fy, Bf, D, and Fc prime, I should say. Okay, so with those, ang Fy natin, once again, is equal to 248 megapascals. So, ito, hindi ko na-explain kung saan natin nakuha to. Alam nyo na yan. And as for the BF and the D, so alam nyo na din paano kunin yan dun sa ating table. And to save us some time, the base of the flange of this section right here is equal to 254 millimeters. And our depth is 253.49 millimeters, I should say. So, ayan. And the area of this, ilista lang natin the area of the this particular figure right here, I mean this particular section right here is equal to 9 to 90 millimeter squared. Okay, so ano ba yung next step natin? Hindi ko na babalik sa slide natin kanina, baka mahilo lang kayo, pero yung next step talaga natin is to get the factored loads. Okay, so since we are only to solve for the LRFD, so LRFD lang yung solve natin. So that is to be PU. Tegal, para ibang color. So PU is equal to 1.2 times dead load, and our dead load would be 450 daw. 450 plus 1.6 times 650. So our answer here would be, sabi yung calculator ko na naman, 1.2 times 450 plus 1.6 times 650. So our answer here would be 1580. So 1580 kilonewtons. So that is to be for the first load factors. And yung sa second natin, yung isang PU natin, PU is equal to 1.4 dead load times 450. And this is to be, calculator ko lang na naman, 1.4 times 450. So that is to be 630 kilonewtons. So with those being said, it is safe to assume that this particular factored load right here would govern kasi mas malaki siya. So meaning it would be critical that way. Okay, so before I move on, any questions? Ay, mukhang wala naman, factored loads na to. Okay, so tapos na tayo sa step 2. So step 3 na agad tayo. Oops, teka lang, kopyahin ko lang ang ating figure sa next slide natin. Oops. Okay, so yan, kinopy ko lang ating figure para dito na tayo mag-solve. Ito na lang pala. Okay, so the next step after step 2 is, of course, self-explanatory, step 3. So, ang step 3 natin is to compute for the bearing area. So, solve for A1. And how do we solve for the value of A1? So, Pn is equal to 0.85 Fc prime. And as you can see here, magkaibang ating base plate and ang concrete pedestal natin. So we would be using the second formula, which is the square root of area 2 divided by area 1. Okay, so ngayon isolve na natin ang ating area 1. Okay, so una, ano ba yung kailangan nating malaman? Yung ating tawag dito, bearing area. So as for the bearing area, kapag bearing area pala, by the way guys, kahit sabihin natin dito na LRFD. So as you can see here, LRFD method, pero kapag kukodin kasi natin yung value ng ating area 1, gagamit tayo ng service load. So itong nominal stress natin. So if that is to be the case, yung PN natin is equal to PU over phi. PU over omega. Teka, tama ba? Oo. So, ayun. Oops, wait lang guys. Ayaw gumana ng aking pen. Wait for a minute guys. Ayusin ko lang yung pen ko. Oops. Wait. Okay. Ayun, kumana na. Okay, so start. Oops, by the way guys, hindi pala, kamali ako ng aking nasabi. So, LRFD, PN, factor load. Okay, PU. Sorry guys, nalito. Okay, erase yung huling sinabi ko. So, PN is equal to PU over phi, right? So, this is for LRFD. Guys, may reklamo ba dito sa equation na to or naintindihan nyo to? Guys, anyone? I mean, everyone. Etong linelaser pointer ko.
Yes, sir.
Okay, so
Yes, sir.
okay, so mga hindi nakagets, PU is equal to VPN, remember? So, cross multiplication, you would be solving for PN. Okay, so if that is to be the case, so the value for your PN, I mean VPN, so ating phi would be, ano na yung ating phi ng ating bearing? So, 0.65. So, ibahin ko yung color. 0.65 times our, teka, PN na pala yung sinasolve natin. So, using this formula right here, sorry guys, lutang. So, gagamitin na, solve natin yung PN, and our PN would be PU over omega. And our PU, once again, is to be 1,580. So, teka. So, 1,580. So, this is to be in kilonewton. So, times 1,000 tayo. So, times 1,000 divided by our value for phi, and our value for phi in bearing would be 0.65. And this is to be equal to, so 0.85 FC prime, but FC1, FC prime area to area 1 yan. So, that is to be 0.85 times FC prime, and our FC prime here would be 21. So, it is written here. Hindi ko pala nasulat, pero sinabi dito ng FC prime natin is to be 21 megapascal. So, nasa given talaga to. Hindi ko lang nailista kanina. So, 21 times the square root of A2 over area 1. And our area 2 is actually equal to 400 by 450. So, ito yung area ng concrete, itong area 2 natin. So, 450 squared. Okay, divided by, ano yung area 1 natin? Actually, yan yung hinahanap natin. So, after this, it would be up to you on how you would be solving for A1. So, pwede namang shift solve, no? Okay lang tayo dun, guys? Shift solve ko na lang for this problem.
Yes,
Yes, sir.
Okay, so ayan. So 1,580 times 1,000. May mali pala yung aking formula. So if you are to look back at our formula a while back, mali talaga to kasi meron pa tayong A1 dito sa labas. So A1 ko ba? A1. Ayan. Okay, so with that being said, erase ko to. So this would be A1. So area 1 times square root of, guys, wait lang, naghang ako. Guys, may nakikita pa ba kayo? I mean, sa screen nyo na aking...
meron po.
Meron. Okay, wait. Laser pointer, may nakikita pa ba kayo?
Meron, sir. Meron, sir.
Buti pa kayo? Sana all. Ako, di ko nakikita. Teka. Ayan. Okay. So, I'm back. Okay, nakikita ko na din yung mga nakikita nyo. Okay, so... Eto, nanulit yung area 2 natin. That is to be 450 squared. So, 450 squared. And our value for our A1 would be A1. So, we would be solving for that. Okay, so... Oh, by the way, guys, baka naman nag-break na. Nandiyan pa ba kayo?
Yes, sir.
Okay, so...
Yes, sir.
Ayan, thank you.
Yes, sir.
Sorry for the technicalities. Technical issues pala. So, naghang lang kasi. So, 0.85 times 21 times shift x. X ba yan? Shift x, I should say, times the square root of 450 squared divided by our area, which is alpha x. So, x. So ang sabi niya dito, the value for our area would be 91,576. So, 91,576. Double check para mag-continue na tayo sa ating problem. 0.65, then 0.85 times 21 times area 1 times 450 squared divided by x. Okay, 91. Syntax error daw. Shift solve pala kasi dapat. So, 91576.91. So, ang unit natin dito would be millimeter squared. So, ayan. Okay, so what would be the next step? So, the next step is for us to check the limits. So, akin lang i-copy-paste itong values natin dito. So, next. So, ayan. Ayan yung ating area 1. So, next up, we would be solving for the limits. So, ang ating limits, if you can remember our limits earlier na dito sa ating values, so BF times D. So, dapat mas malaki ang ating base plate kaysa sa area na ino-occupy ng ating flange. So, BF times D. So, BF times D. And na-realize ko lang na nanggaling na ako doon kanina, hindi ko pa memorize yung ating formula. So, 254 times 253.49. 254 millimeters times 253.49 millimeters. So, if we are to solve for this, teka, yung calculator ko lang sandali. $254 times 253.49. So, this is to be 64.386. So, 64,386.46 millimeter squared. So, the value of our A1, so 91576.91 millimeter squared. This is to be greater than our value here, itong 64,386.46 millimeter squared. So, if we are to check that, check yan. So, pasok tayo sa limit na yan. So, another limit that we should consider is this limit right here. So, etong 1.7 FC prime AB. So, eto. Kailangan nating isatisfy yan na tama dapat yan. Okay. So, with that, ano na yung formula natin doon? So, that is to be, so yung VPN natin, 0.85 FC prime natin, 21 pala. 21 times area 1. So, area 1 natin is 91576.91 times the square root of 450 squared divided by 91576.91. So, that should be less than or equal to 1.7 times FC prime area 1. So, FC prime would be 21 and our area 1 would be 91576.91. So, i-check lang natin to. And eto, pag i-solve natin yan, sige, solve na lang ulit natin. So, 0.85 times 21 times 91576.91 times square root of 450 squared times 450 divided by 91576.91. So, ayan siya, 243. So, check natin kung tama to. So, 1.7 times 21 times 91576. Oops. Di pa ako tapos eh. 0.91. Okay, so this is to be 3269295.69. So this is to be checked as well. So if you have surpassed both of these limits, so we would be using this value right here as the value for our A1. Okay, so yan ang ating A1 na gagamitin para sa ating, anong step na tayo? Step 4. Okay, ito pala yung step 4 by the way. So this is to be step 4, check limits. Okay, so kopyahin ko lang ulit ang ating area para sa ating next slide. So, ayan ang ating area. So, after step 4, of course, we would be doing our step 5. So, ang step 5 natin is to determine the dimensions. Okay, so if that is to be the area 1, if you can remember our formula, yung ating n. So, n is equal to the square root of area 1 plus delta, where delta would be 1 half 0.95d minus 0.85 the base of the flange. So direct substitution. So for us to get the value of delta, that is to be 1 half times 0.95 times, nakalimutan ko ng ating d. So ang d natin would be 253.49 and ang base of flange natin would be 254. Okay. So 253 point, teka, ano ulit yung 254? Okay, 253.49 minus 0.85 254. Okay, so for that, our value for delta would be 0.95 times 253.49 minus 0.85. 0.8 lang dapat to eh. 0.8 lang. Okay, palagi ko nakakalimutan. 0.8254. So our value for delta would be 18.81. So 18.81 millimeters. Okay, so ulitin ko lang ang ating solution for delta para lang sigurado tayong hindi ako nagkamali sa aking calculation. So 0.95 times 253.49 minus 0.8 times 254 divided by 2. So 18.81. Okay. And by that, the value for n would be equal to the square root of area 1, and the square root of area 1 would be the square root of 91576.91 millimeter squared plus our delta. So that is to be 18.81 millimeters. So bakit meters ang laki? Okay. So our answer here would be, so square root of 91576 0.91. So 91576.91 plus 18.81. So our answer here would be 321.427 mm. So this is to be the depth of your base plate. But guys, i-round up natin to the nearest 5 mm for our classworks and for your quizzes as well. So this should be 325 mm. So ito pala, use. Okay, used. Okay, so ito yung gagamitin nating dimension ng ating n. So for the value of our base, so our base would be equal to the area 1 divided by n. So etong formula na to, yung tinatanong ko sa inyo kanina kung naintindihan nyo. Okay, so that is to be 91576.91 millimeters squared divided by n. So anong n ba gagamitin natin? So would it be this or would it be this? So ito na yung gagamitin natin eh. So that is to be 325 millimeters. So the answer here would be 91576.91 divided by 325. So 281. So round up ulit natin, pero lagay lang muna natin yung theoretical value, 281.78. So use 285 mm. So we already have our B and our N. Guys, nakasunod pa ba?
Yes, yes, sir.
Okay, so ano na yung ating step 6? So for our step 6, saan na yung aking pen? Okay, so for step 6, since we already have our, so meron na tayong B and meron na tayong N, we would be checking the bearing capacity. So check bearing stress. Okay, so paano na ulit natin i-check ang ating bearing stress? So just make sure that your VPN is greater than or equal to PU. So this is for LRFD, and since yung problem natin would only be about LRFD, so ayan. So kung natatandaan nyo yung formula natin kanina for the bearing stress, so that is to be phi 0.85 FC prime, ano next? Area 1 times the square root of area 2 over area 1. Okay, so this should be less than or equal to, ano yung PU natin? 1580 ata eh. Yes, so ito, 1580. Ito yung PU natin. So that should be greater than or equal to 1580 times 10 raised to 3 newtons. Okay, so solving for this, our FC prime would be, say, lagay ko na lang, so 0.65 times 0.85 times FC prime, and our FC prime once again is 21 megapascal, and our area 1 is isolve pala muna natin. Okay, so for area 1 is equal to base times depth, so B times N, and our B and our N respectively would be 325 and 285. Okay, so anong sagot dyan? Teka nga. Wala na tayong space. So, okay, so 325 times 285, that is to be 9265. And since alam na natin yan, erase ko na lang to para, kasi wala na tayong space. Okay, so 92625. 92625. So this is to be 92625. Then meron ko ulit dito 92625. So ayan. Times the square root of ano yung area 2 natin? What is to be 450 squared. So, i-check natin kung ano yung answer dito. And our answer here would be 0.65 times 0.85 times 21 times 92625 times the square root of 450 squared divided by 92625. So, equal sign 1589. So, oops. 1589015.75 newtons. So, is it greater than or equal to 1580 times 10 raised to 3 newtons? So, yes. So, if that is to be the case, so, pwede na tayo. So, ayan. Then, lagyan natin ng conclusion. So, adequate. For bearing. Okay, so ayan. So, adequate tayo for bearing. So, tapos na ba tayo? So, meron na tayong B, meron na tayong N. Kulang na lang tayo ng thickness. So, that is for number 7. So, last step, determine the thickness. And our value for T in LRFD is equal to L times the square root of 2 times PU divided by 0.9 Fy Bn. Okay, so meron na tayong B. Sige, ililista ko na lahat. So, as for our PU, is equal to 1580 times 10 raised to 3 newtons. So, meron na tayong PU. Fy, so sinabi kanina, 836 siya. So, this is to be 248 megapascals. And as for our B, and as for our N, okay, so paulit-ulit tayo. Ulitin ko lang, nakalimutan ko. So, that is to be 325 and 285. So, 285 ang base and 325 ang N. So, this is to be millimeters and millimeters. And as for our L, di natin pa alam yan. So, etong L na to, L is the greatest the greatest value between M, N, and lambda, and prime. So, solve natin tong isa-isang to. Kung babalikan man natin yung figure, instead of balikan natin yung figure, sunduin na lang natin yung ating figure. Teka. Copy ko na lang yan. Lagay natin sa ating last page. So, ayan. Confirmation guys, nakita nyo ba yung figure?
Yes, sir.
Yes.
Yes, sir. Yes, sir.
Okay. So, from that, we would be solving for the value of N and M. So, etong N na to, and etong M na to. So, unahin natin yung ating M. So, M, looking at that particular figure right there, that is to be equal to N minus 0.95D divided by 2. Okay, so nakalimutan ko ulit ang ating base and ang ating depth. So, copy-paste ko na nga lang. So, wait lang. So, lagay ko na lang siya somewhere here. Ewan kung nakita nyo pa sa screens nyo. Pero yan, lagay ko na lang muna dito. Okay, so substituting known values, that is to be, ano yung value natin ng N, 325 minus 0.95 times D, and our D would be 253.49. Ang pangit naman ang spacing ko. Okay, iurong ko lang sandali. Ayan. So, D is equal to 253.49. So, we would be dividing this by 2 to get the value of our M. So, from that, this should be 325 minus 0.95 times 253.49 divided by 2. So, our M right there would be 42.1. So, ano ba yung mga competition nitong M na to? So, ito yung N din. So, as for our N, diretsahin ko na dito sa equation na yan. That is to be 0.8 ng ating, ano ba yung base natin? That is to be 285. So, minus, ano yung minus natin? 0.8 ng base ng flange. And the base of the flange is to be 254. Okay, so ayan. We would be dividing this by 2. So our value of N, so wait lang, once again, this is the value of N. So kunin nyo lang yung value na yan by inspection. So 285 minus 0.8 times 254 divided by 2. So that is to be 40.9. So 40.9. Okay, so next up, we would be solving for the value of your lambda n prime. So as for the lambda n primes, this is to be 1/4 of B times DF. BF times D. So that is to be 254 times 253.49. Erase ko muna yan pala para makita nyo yung formula. So, ang formula dyan would be BF times D. So, okay, so that is to be 1/4 times the square root of 254 times 253.49. So, our value for lambda n prime would be equal to the square root of 1/4 pala, 1/4 times the square root of 254 times 253.49. So our answer here would be 63.44. So okay, mayroon na tayong values ng mn and lambda n prime. So with those, mamimili tayo ngayon between this, and this, kung ano yung pinakamalaki, and by inspection, yung ating red dyan, which is yung lambda n, shucks, bakit ko in-erase? Okay, which is yung lambda n prime, that is to be the governing L. So if that is to be our governing L, okay, para may space ulit tayo, iangat ko lang ito dito. Then, erase na natin itong figures na nasa baba. Okay lang tayo doon, guys? Naintindihan naman? So, wait lang, labas ko lang. Guys, ano?
Yes po.
Okay, how about for the others? Naintindihan kung bakit itong nag-govern? Kasi, yan yung mas malaki. Simple as that. Okay? Naintindihan, guys?
Yes, sir.
Ayan.
Yes, sir.
Okay, so erase ko na to Okay na tayo dito. Move on na tayo dyan. Okay, so ano bang next? Solve na natin yung thickness. So for the thickness, okay, for the thickness, that is to be, so I will just be substituting the known values in this equation right here. So as for the value of L, so gawa tayo ng color coding, so 63.44 times the square root of 2 times PU, and our PU would be 1580. times 10 raised to 3 newtons. So divided by 0.9, and our Fy would be 248. And our B and our N would be 285 and 325 millimeters respectively. So solving for this, we already have the thickness of our base plate. So 63.44 times the square root of 2 times 1580 times 1000, 2 times 1580 times 1000 divided by 0.9 times 248 times 285 times 325. Okay, so the thickness that we would be using for our base plate would be 24.8 millimeters. So this is to be the theoretical value. But in our classroom discussion and in your quizzes soon, the value for your T, I mean, every value of the dimensions of your base plate should be rounded up to the nearest 5. So round up, ha. So 25 millimeters. So this is to be your thickness. So with those, we already have the dimensions of our base plate. So ang ating B would be 285 mm. Ating D or ang N natin. So ang ating depth ng base plate would be 325 mm, and the thickness of our base plate would be 25 mm. So yan yung dimensions ng ating base plate. So if this is to be your base plate, okay, so etong thickness natin na to is 25 mm. Ewan ko nakikita nyo. So 25 mm. And eto daw, yung depth, I mean yung BF niya is to be, wait lang, itong mga dimensions na to is to be yung B and yung N natin, which is, once again, nakalimutan ko. So, para may sulat lang natin. So 285 and 325. So dito 325 and 285. So okay, that pretty much sums up our lesson for today. So okay, meron ba tayong questions dyan?
Wala na, sir.
Okay, so if there are no more questions, you are now dismissed. So nice meeting you all. So if there are any questions, feel free to message me. So ayun, thank you everyone for attending.
Bye, sir.
Bye-bye.
Thank you,
Bye,
sir.
sir.
Thank you
Thank you,
also.
sir.
Bye-bye.
Bye, sir.
Bye.